In March 2016, over 200 million people watched a machine do something that was supposedly decades away.
Oh, yeah. It was a completely massive moment.
Right. I mean, during the second game of this historic Go match against the world champion Lee Sedol, the AI system played a move 37, and it was so profoundly creative, so completely alien to like thousands of years of human strategy that expert commentators literally thought it was a glitch.
Right. They thought the machine had broken.
Yeah, they thought it broke, but it wasn't. It was a calculated, devastatingly brilliant piece of strategy. But here is the tension we are looking at today. The company behind that move, DeepMind, was founded with this almost breathtakingly broad mission statement to solve intelligence and then use it to solve everything else. And while the trajectory from mastering ancient board games to completely transforming our ability to predict the shapes of proteins is historic, there is this massive leap in logic that happens in the public imagination.
Yes, absolutely.
Like success in a board game or in biology does not itself prove that artificial general intelligence or AGI and, superintelligence are just around the corner or even inevitable.
No, it doesn't. And the distance between a highly capable domain-specific tool and a universally intelligent system is vast. Winning a board game means mastering a heavily constrained environment.
Right.
Navigating the chaotic, open-ended nature of the real world is a fundamentally different scientific challenge.
Which brings us to the central question for this deep dive.
Yeah.
Can the quest to solve intelligence accelerate scientific discovery without concentrating power or creating systems their builders cannot reliably control?
Yeah, that is the big one.
Yeah, that is the question at the core of our main source today, Sebastian Mallaby's book, The Infinity Machine. And so over the next 15 minutes or so, we are going to follow the path of DeepMind's co-founder, Demis Hassabis, from his roots in chess and game design and neuroscience straight into DeepMind's founding. We'll track the breakthroughs of reinforcement learning AlphaGo and AlphaFold. Then we'll get into Google's acquisition, the generative AI race, and finally confront those massive unresolved questions about AGI, safety, scientific power, and governance.
It is a remarkable trajectory to analyze, especially when you look at the mechanics of how these milestones were actually achieved.
Okay, let's unpack this. In our discussion today, I'm going to focus on protecting the human story. I want to look at Hassabis' raw ambition, his deeply rooted scientific curiosity, and the sheer undeniable excitement of these historical breakthroughs.
And as we go through this, I want to play referee.
Please do.
Because there's a lot of myth-making in the history of artificial intelligence. What's fascinating here is how often the history is flattened into hype. So my role is to protect the technical precision.
Right.
I will ensure we distribute credit, accurately apply rigorous source criticism, and constantly separate measured achievements from institutional interpretations and, speculative predictions about the future.
I love that setup.
Yeah.
So let's start at the foundation. Mallaby's book paints this picture of a childhood spent entirely inside closed world games. Hassabis wasn't just casually playing. He was a chess prodigy who became a massively successful video game developer as a teenager.
Working on games like Theme Park.
Yeah, exactly, Theme Park. And he realized early on that the artificial intelligence in games was incredibly rigid.
Yeah.
It was just simple state machines reacting to basic triggers. So he pivots. He goes into neuroscience, specifically looking at the hippocampus to study how the human brain actually handles memory, imagination, and planning.
Right.
And then he used those biological mechanisms as a blueprint for machine architecture. But I have to push back a little on this foundational premise.
Okay.
Treating the human brain like a piece of software that can simply be decomposed and reconstructed. I mean, isn't that a bit too tidy of a metaphor? It feels like assuming the brain is just a biological hard drive that we can plug into a motherboard.
Yeah, we have to draw a hard line there, which is why we need to use a mental sorting system for this deep dive.
Okay.
Let's categorize the claims we are exploring into 4 distinct buckets: observed facts, theoretical tools, model-dependent interpretations, and completely speculative predictions.
Okay, I like that. So how does that apply here?
So applying that, to your point, the documented history of DeepMind's founding and Hassabis' background in chess and neuroscience, those are observed facts. We have the historical records.
Right, we know he did those things.
Exactly. However, interpreting human intelligence as something that can be perfectly reverse-engineered from neuroscience is highly model-dependent.
I see.
It relies on a very specific mechanistic philosophy of how cognition works. Biological inspiration is incredibly useful for designing algorithms, but an artificial system doesn't have to perfectly reproduce human brain chemistry to process information effectively.
So the metaphor is a map, but the map is not the territory.
Precisely. But there is a very specific reason why Hassabis's background in game design was the perfect incubator for drawing that map in the first place.
Why is that?
Think about what a game actually is. Games are arguably the ultimate research environments for early AI because they provide clear, unambiguous rules,
Okay.
strictly measurable rewards like a score, and extremely rapid feedback loops. If you want to train an algorithm to figure out what actions lead to success, you need an environment where success is mathematically definable.
Right, you need a win state.
Exactly. A chessboard or a video game provides that perfectly closed loop.
Here's where it gets really interesting because DeepMind took that theory and threw it into the ultimate closed world crucible, which is the game of Go. Let's go back to March 2016. DeepMind builds AlphaGo to play against Lee Sedol. And the tension surrounding this was unbelievable because Go is not like chess.
Not at all.
Go has more possible board configurations than there are atoms in the observable universe.
Yeah, it's mind-boggling.
It is. When IBM's Deep Blue beat Garry Kasparov at chess in the 90s, it largely used brute force calculation, just rapidly looking ahead at every possible move. You mathematically cannot do that with Go.
Right. You cannot brute force infinity. To understand why AlphaGo was such a cultural shockwave, we have to look at how it actually worked under the hood. DeepMind combined several theoretical tools to solve this. First, they used deep neural networks, which are algorithms inspired by the visual cortex, to simply evaluate the visual state of the board and determine who is currently winning.
So just looking at the board and saying, oh, black is ahead.
Yes, basically. Second, they used advanced search algorithms, specifically Monte Carlo tree search, to intelligently narrow down which future moves were actually worth looking at.
Okay, so pruning the tree of possibilities.
Right, so you don't calculate everything, just the promising stuff. Third, they trained the system initially on a massive data set of expert human games so the machine could mimic human intuition.
But mimicking humans doesn't get you. Move 37. Move 37 was completely alien.
Exactly, and that brings us to the fourth and most crucial theoretical mechanism, which is reinforcement learning. Once AlphaGo learned the basics from humans, it was set up to play millions of games against slightly different versions of itself.
Self-play.
Yes. Self-play. In reinforcement learning, an agent takes an action in an environment, and if that action leads to a win, it receives a mathematical reward reinforcing that behavior. Over millions of iterations, AlphaGo discovered strategies that humans had never conceived of in 3 millennia of playing the game. Wow. These theoretical mechanisms combine to produce the 4-1 victory, which stands as an undeniably observed milestone in AI history.
So to put that into perspective for the listener mastering Go with these tools is kind of like building a flawless mathematical clockwork inside a vacuum.
Right.
It is astonishingly impressive engineering, but it doesn't mean that same machine knows how to navigate the messy, chaotic, open-ended reality of a human street where the rules change every 5 seconds and the rewards are completely subjective.
The clockwork analogy captures the engineering, but it is actually more like a vacuum-sealed maze.
Yeah.
The AI has explored every possible path and knows exactly how to reach the center. But the moment you drop that same AI into a real physical forest with changing weather, uneven terrain, unpredictable animals, it is completely blind. Generality across complex board games or mastering a suite of Atari video games is fundamentally not equivalent to general intelligence across human life. We must rigorously correct that misconception AlphaGo was a landmark achievement in a defined domain. It did not prove that AGI is imminent.
But a Go board is completely sterile. Like you said, it has no friction, no changing laws of physics. The real test of Hassabis' mission wasn't to whether AI could beat a human at a game, but whether it could break out of the loop and decode the wet, chaotic rules of physical reality.
Yes, the jump from games to science.
Exactly, which brings us to the pivot to AlphaFold. We go from winning games to accelerating scientific discovery. They pointed these massive AI tools at protein structure prediction, and the impact was just monumental. Think about the medications in your cabinet right now. Historically, understanding the shape of a single protein to create a drug could take a scientist 5 years of painstaking X-ray crystallography.
It was a massive bottleneck for biology.
Huge. But DeepMind eventually released a database containing over 200 million predicted protein structures. That is essentially almost every protein known to science dumped right into the public domain.
And to appreciate that breakthrough, we have to understand the mechanics of the problem. A protein is basically a long chain of amino acids.
Yeah.
In nature, that chain folds itself into a highly complex 3D shape in milliseconds.
Right.
But mathematically, the number of ways it could fold is astronomically large. It's a concept known as Levinthal's paradox. For decades, scientists were essentially trying to fold a massive, complex origami swan in the dark, guessing where the creases should go.
Oh, that's a good way to put it.
Yeah, and AlphaFold 2 worked by shining a light on the evolutionary history of similar proteins. It treated the amino acids like a spatial graph, predicting which parts of the chain would magnetically attract and which would repel, slowly pulling the 3D structure into focus.
And that achievement was recognized at the highest level of science, right?
Yes, the 2024 Nobel Prize in Chemistry serves as our observed evidence of its scientific significance. But this is where we must step in to ensure accurate historical attribution.
Right, because it wasn't just one person.
Exactly. The narrative of the lone genius is almost always a fiction in modern science, and the Nobel Committee rigorously preserved shared institutional credit.
Okay.
Demis Hassabis and John Jumper of DeepMind jointly received one half of the prize for protein structure prediction.
And the other half.
The other half went to David Baker for his entirely separate, though related work on computational protein design.
Ah, okay. That distinction is incredibly important. One half is for predicting the structures that already exist in nature, and the other half is for designing entirely new structures that don't exist.
Spot on. And furthermore, we need to correct another major misconception that often follows these headlines. AlphaFold did not solve biology. The structures in that 200 million database are exactly that, predictions.
Right. It's like AlphaFold gave us the high-resolution blueprints for a billion different car engines, but just having the blueprint doesn't mean we automatically know how the engine sounds when it's running or how to fix it when it breaks or how it behaves in heavy traffic.
That's a perfect analogy. The structural blueprint is a prerequisite, but it is not the entirety of the biological reality. These predictions do not automatically produce safe, effective medicines, nor do they replace traditional experimental biology.
You still have to do the work.
Yes, you still need wet labs to understand protein dynamics, how they move and interact in complex cellular contexts, and you certainly still need grueling clinical translation to turn a molecular insight into a viable drug that can safely be given to a human being.
So what does this all mean for the reality of building these AI systems? Because generating those 200 million biological blueprints and training those neural networks to play millions of games of Go requires something else, entirely astronomical amounts of capital and computational power.
Oh yeah, the money involved is staggering.
It is. The narrative in Mallaby's book has to transition from a plucky, independent research lab to the realities of a corporate titan. We have to talk about Google acquisition of DeepMind, the culture clashes, and the generative AI race. Because the landscape shifted under DeepMind's feet.
It really did.
DeepMind was highly focused on this reinforcement learning path. Agents taking actions to maximize rewards, but rival labs went in a completely different direction. Competitors proved that if you just scale up prediction models over enormous internet-sized text corpora, what we now call large language models, or LLMs, you could yield massive generalized conversational and coding abilities.
If we connect this to the bigger picture, the history of this transition is incredibly tangled. Using our framework, the interpretations of these corporate motives, the internal leadership clashes between founders like Hassabis and Mustafa Suleyman over autonomy, and the strategic pivots required to compete in the generative AI race. These are deeply model dependent.
They depend on who you ask, basically.
Exactly. It is not a clean, linear story of a single visionary making all the right bets. It is a highly complex web of rival corporate labs, open research communities, university breakthroughs, and the foundational semiconductor chip firms that manufacture the hardware, making this scale of compute possible.
Right, because LLMs are a different beast.
Large language models operate differently than reinforcement learning agents. Instead of acting in an environment for a reward, LLMs are essentially statistical engines predicting the next most likely word based on billions of parameters.
Which brings up a critical tension regarding the scale of these operations. If building state-of-the-art AI requires this much expensive compute, these massive multi-billion-dollar data centers and specialized silicon, isn't it less like a lone genius tinkering in a lab and more like building a modern particle accelerator?
That's a very apt comparison.
Where the massive tech conglomerates holding the purse strings ultimately dictate the direction of the science based on commercial viability.
The economics certainly point in that direction, which forces us to correct a pair of linked misconceptions about the reality of the AI industry today.
Okay, what are they?
First, scientific importance does not automatically guarantee equitable public benefit. A tool can be revolutionary for structural biology, but still be gated by intellectual property laws, API access fees, or corporate priorities.
Right, just because it's good for science doesn't mean everyone gets to use it for free.
Exactly. Second, there is immense public debate about the timeline of superintelligence, when or if a machine will truly outsmart us.
Yeah, that's all anyone talks about.
But uncertainty about the arrival of superintelligence does not make the present-day economic footprint of AI unimportant. Even if AGI is 50 years away or never arrives at all, the corporate control over the compute, the infrastructure, and the data that powers these systems represents an enormous concentration of capital and influence right now.
It is a sobering reality check. We get so caught up in debating the sci-fi endpoints, whether the AI will wake up or take over, that we ignore the very real earthly economics of who owns the printing press today.
Very true.
So let's bring all these threats together and evaluate the core of the material we've been digging into, separating the verifiable history from the speculation.
This is where we apply the final label from our framework. Any claims regarding machines achieving actual consciousness, the exact timelines for when AGI will arrive, the inevitability of a superintelligence system, promises of guaranteed global abundance, or the assumption that developers will be able to maintain complete fail-safe control over highly advanced AI, all of these remain entirely speculative.
They are hypotheses, not history.
Precisely.
So arriving at our balanced verdict on Sebastian Mallaby is the Infinity Machine. It is an incredibly compelling, deeply reported biography. It serves as an essential history of DeepMind and the modern AI boom. It is at its absolute strongest, its most undeniable when it is detailing the documented people, the institutional chess moves, and those breathtaking observed breakthroughs like the mechanics of AlphaGo and AlphaFold.
Its rigorous documentation of the past is definitely its greatest asset. However, it rightfully remains highly provisional regarding the ultimate destination called superintelligence. The path from a brilliant protein predictor to a universally capable, controllable artificial mind is not just a matter of adding more computer chips. It requires solving fundamental, currently unanswered scientific and philosophical mysteries about the nature of intelligence itself.
Well said. And on that note, we want to be very clear with our listeners. This has been an independent Cosmora HQ book overview, and it is not an official or complete audiobook. We highly encourage you to seek lawful access to the published book to get the complete narrative, the nuances of the reporting, and Mallaby's full analysis. And if you enjoyed this deep dive, please subscribe, leave a comment, and share it with someone who loves getting past the hype of technology.
This raises an important question, one that sits exactly at the intersection of the incredible scientific promise we've discussed and the highly concentrated reality of how these tools are built.
If AI can transform science before it becomes general intelligence, who should decide which problems it solves and how its power is governed?